Captions in English, please. So this is the fourth video of chapter 8, and we will be counting molecules by mass or vice versa. So for elements, the molar mass is the mass of 1 mole of atoms of that element. For compounds, the molar mass is the mass of 1 mole of molecules or formula units of that compound. So molecules for molecular compound, but we say formula units for ionic compound because ionic compound do not contain individual molecules. They contain formula units. And so we convert between the mass of a compound and the moles of the compound using the molar mass. And then we can calculate the number of molecules or formula units from the number of moles using the Avogadro number. So that's how we count molecules by mass. So let's go through an example here where we will convert between mass and moles of a compound. And so converting between mass and moles of a compound requires the molar mass. And so the molar mass of a compound in grams per mole is numerically equal to the formula mass of the compound in atomic mass unit. And the formula mass for a compound is the sum of the atomic masses of all the atoms in a chemical formula. So for example, the example we have below here is for CO2. The formula mass of CO2 is found by taking the atomic mass of carbon one time, because there is only one carbon in the formula, plus 2 times the atomic mass of oxygen. And oxygen is 16.00 atomic mass units. And you find this in the periodic table. It's those numbers that have decimals and that are typically below the symbol or below the name. So when you do 1 times 12.01 plus 2 times 16, that's a sum of 44.01. So you add all of the contributions of each atom, and that's the mass for the whole formula. So the formula mass is expressed in atomic mass unit, but the molar mass will be the same number, but in grams per mole. So the molar mass of CO2 is 44.01 grams per mole. The numbers are the same, it's just the unit that is changed to grams per mole. And so the molar mass allows us to change between a mass and number of moles of a compound or vice versa. And so we'll see that in this example. And the question is to calculate the mass in grams of 1.25 moles of water. So we have 1.25 moles of water, that's the given amount. We want to find the mass in grams of water. And so we have this number of mole, we want the grams. So we know we will need the molar mass because the molar mass relates the grams to the moles. So we need to calculate the molar mass of water. And this is the number, but let's look at how we do this. You take the mass of an hydrogen atom, and it's 1.01 atomic mass unit, multiplied by 2, because there is 2 hydrogens in the molecule of water, plus 1 time the molar mass, sorry, the atomic mass of oxygen, so 16.00 atomic mass unit. You add all of this together and you obtain 18.02 atomic mass unit. That's the mass of one formula, one molecule. But we know now that it's the same number for the molar mass. So 1 mole of water is also 18.02 grams of water. So, 18.02 grams per mole can be written as an equality that says 1 mole of water is 18.02 grams of water. So that's the molar mass equality here. And that will allow us to change the moles into grams because we are starting with moles and want to finish with grams. The conversion factor that we will write from this equality will be such that the moles are on the bottom because we start with moles and we want to cancel the units of moles, and we'll have the grams of water on top, so the 18.02 grams on top. So when you see the solution, it looks like this. It's 1.25 moles of water. That's the given amount written in the numerator, multiplied by 18.02 grams of water over 1 mole of water. This way the moles of water cancel, the units cancel. And in the calculator, you do 1.25 times 18.02, and that's 22.525. Here it's already rounded to 3 sig figs for you because the given amount had 3 sig figs, so we need 3 sig figs. So it's rounded to 22.5 because what comes after the 5 is a 2, so you keep the 5 a 5, you round down. So 22.5 grams of water contain 1.25 moles of water. So to give you an idea, 18, 22 grams, this is about a tablespoon or a mouthful of water. So when you have a mouthful of water, that's 1 mole of water molecules. Let's go through another example where we will convert between moles, between number of molecules and the mass of a compound. So the question is, what is the mass in grams of 5.90 times 10 to the 24th SO2 molecules? So we are given this number of molecules, SO2 molecules. So a large number, 10 to the 24th. We need to find the mass in grams of the SO2. So this is between a number of molecules and grams. There is no direct relationship between number of particles and grams. We know how to count number of particles and then change that into moles, and then from moles to grams. So we will need to do 2 conversions there. So the first conversion will change the number of molecules to moles using the Avogadro number and the definition of the mole. So 1 mole of SO2 is 6.022 times 10 to the 23rd molecules of SO2. Once we have changed the molecules to moles, we can then change the moles to grams using the molar mass of SO2. Molar mass of SO2 is 64.07 grams. Let's see how we found this. So taking the periodic table to search for the atomic mass. So the formula mass, the mass of just one formula of SO2 is, you take 1 time the atomic mass of sulfur, 32.07 atomic mass unit, plus 2 times the atomic mass of oxygen, 16.00 atomic mass unit. Adding this, so basically it's 32 plus 32, and that's why it's 64.07 there. 64.07 atomic mass unit, that's the mass for one formula of SO2. But as we know now, the number is also the same when we are talking about grams per mole. So the molar mass is 1 mole of SO2 equals 64.07 grams. So from this, let's look at the concept map. We start with molecules of SO2. We want to change that to moles of SO2 and then grams of SO2. So the first conversion factor will need to have the number of molecules on the denominator, and that's going to be 1 mole of SO2 over the Avogadro number of molecules of SO2. This way we can cancel molecules of SO2 as a unit. And then the second conversion factor will have the 1 mole on the denominator so that we can cancel the units of moles, and then the grams, per mole on top. So 64.07 grams on top. So if we look at the solution, it looks like this. So you start always your calculations with the given amount. The given amount here, it looks like it's in the middle, but it's really in the numerator. You must see it as a number in the numerator. So you can draw a line below and write a 1 in the denominator to remind yourself this is in the numerator. multiplied by the first conversion factor that has the Avogadro number on the bottom and 1 mole on top. This way we can cancel molecules of SO2. The next conversion factors has the moles on the bottom and the grams of SO2 on top because we want to cancel moles of SO2. So we have grams of SO2 in the end because that's the only unit left over. So in the calculator, you do 5.90 10 to the 24th. Remember to use the scientific notation and the EE key. Multiply by 64.07 divided by 6.022 10 to the 23rd. And here it is important you use the scientific notation again, because if you don't use parentheses or don't use the scientific notation, you may have the times 10 to the 23rd be moved up to the numerator by the calculator because it will not understand it's in the denominator. And so the calculator answer is 627.720, etc. We need to keep 3 sig figs because the given amount has 3 sig figs. The molar mass has 4 sig figs. The Avogadro number has 4. So the limiting number of sig figs is 3. So we keep the 6 to 7. What comes after the 7 is another 7. So the 7 will be rounded to an 8. And that's why the final answer is 628 grams of SO2. Let's do some concept check now. We will do 2 and we'll start with A. So how many calcium sulfate formula units are in a plaster statue with a mass of 133 kilograms of calcium sulfate? So what is given here? The mass of calcium sulfate in kilograms, 133. We want to find the number of formula units of calcium sulfate in that mass. So we have a mass, we want a number of formula units, so a number of particles. And we know that there is no direct relationship between mass and number of particles. And we know that we need to go through moles. So, but first, before we can use the molar mass, we need to change the kilograms into grams, because molar mass is in grams per mole. So 1 kilogram equals 1,000 grams will allow us to change the kilograms to grams. Next, we need to calculate the molar mass, because from the grams we can calculate number of moles. And for this, we need the formula mass, or the molar mass of calcium sulfate. So there is 1 calcium in the formula, and its molar mass, the mass of 1 mole of calcium is 40.08, plus the mass of sulfur, 32.07, plus 4 times the molar mass of oxygen, 16.00 grams per mole. 4 times because we have 4 oxygen in that formula. And that's a total of 136.15 grams per mole. So we will use this as the molar mass for calcium sulfate. So next, once we have the moles of calcium sulfate from the grams, we can then calculate the number of particles or the number of formula units of calcium sulfate using the definition of the mole and the Avogadro number. And that says 1 mole of calcium sulfate is 6.022 times 10 to the 23rd units of calcium sulfate. So we have 3 equalities and so 3 conversion factors, because we have to go from kilograms of calcium sulfate to grams of calcium sulfate using the 1 kilogram equal 1,000 grams. And so because we start with kilograms, the kilogram will be on the bottom, the grams will be on top. Next, from the grams of calcium sulfate, we will change that to moles using the molar mass. And because we have grams in the numerator in the previous conversion factor, we will use the molar mass with the 1 mole on top and the grams on the bottom, because we want to cancel units of grams. In the next step, we will change the moles of calcium sulfate to formula units of calcium sulfate. And for this, we will need to use the definition of the mole. And because we have 1 mole in the numerator in the previous conversion factor, we will need the 1 mole on the bottom of the final conversion factor. And then the Avogadro number on top. So the solution looks like this. We start with the given amount of 133 kilograms of calcium sulfate, multiplied by the first conversion factor such that the kilograms cancel. So 1 kilogram on the bottom, 1,000 grams on top. Next, we want to cancel grams. So we have 136.15 grams of calcium sulfate on the bottom and 1 mole on top. Grams cancel. And then times the Avogadro number of units of calcium sulfate over 1 mole. This way, the moles cancel. So we've canceled all units except the number of formula units of calcium sulfate, which is what we want. In the calculator, you do 133 times 1,000. We can divide now by 136.15 and then multiply again by 6.022 10 to the 23rd. Again, use the EE key when you have an exponential part of a scientific notation. This is equal to 5.8826 10 to the 26. So when you have numbers in scientific notation, it's important to not forget to see what is the exponent. Sometimes people report the value without reporting the exponential part. And here, if you are missing the 10 to the 26, it's a completely wrong value. So that's the calculator answer. We need to round to 3 sig figs because of the given amount. The definition of the kilogram versus gram is exact. The 1 moles are exact. And the molar mass has 5 sig figs. The Avogadro number has 4. So the limiting number of sig figs is 3 from the given amount. So we need to keep the 5.88. What comes after the 8 is the 2, so we will keep the 8 and 8. And times 10 to the 26. Don't forget to report the times 10 to the 26. Formula units of calcium sulfate. So we see that, so does it make sense here? We have a quite heavy mass of calcium sulfate compared to the molar mass, right? Let's say it's 1,000 times more, because the molar mass is 136 grams per mole for calcium sulfate. And here we have 133 kilograms. So it's 1,000 times more than 1 mole. So that means we have 1,000 moles. And the Avogadro number times 1,000 is about 6, 10 to the 26. You add 3 to the exponent, and that's like multiplying by 1,000. So this answer makes sense. Let's go through the second concept check, B. A sugar crystal contains 1.8 10 to the 17 molecules of sucrose, and the formula for sucrose is C12H22O11. What is the mass of the sugar crystal in milligrams? So we are given a number of molecules of sucrose, C12H22O11. It's a large number, of course. We want to know the milligrams of that sugar crystal. So in milligrams. So we have a number of molecules and we want milligrams. Of course, there is no direct relationship between these two units. And so because we have a number of particles, number of molecules here, we will need to change that first to moles. From the moles, and let's write this equality. 1 mole of sucrose is 6.022 10 to the 23rd molecules of sucrose, C12H22O11. So this will allow us to change molecules to moles. Next, we want to change the moles into grams using the molar mass of sucrose. And so let's calculate the formula mass. So sucrose has 12 carbons in it. So you do 12 times the atomic mass of carbon, 12.01, plus 22 times the molar mass of hydrogen, 1.01, plus 11 times the molar mass of oxygen, 16.00. And calculating all of that, you come up with a total of 342.34 grams of sucrose in 1 mole of sucrose. Above it says formula mass. Formula mass corresponds to the mass of one molecule. But if you change the units of atomic mass unit, then you change that to grams per mole, then you get the molar mass. And so 1 mole of C12H22O11 has a mass of 342.34 grams of sucrose. So this will allow us to change the number of moles to grams. And finally, we need to change the grams to milligrams using the fact that 1 milligram is 0.001 gram, right? The prefix milli has a value of 0.001. So you change the milli by its value and keep the base unit of grams. So we have 3 conversion factors. And so the concept map look like this. We start with molecules of sucrose. We will change that to moles of sucrose. From moles of sucrose, we will change that to grams of sucrose using the molar mass, and then change the grams to milligrams of sucrose. So we need 3 conversion factors. The first conversion factor will convert the molecules to moles. And for this, you use the Avogadro number, and it will be in the denominator because we need to cancel molecules, number of particles of sucrose. And the 1 mole on top. Next, we want to change the moles into grams. So we will use the molar mass such that the grams will be on top and the 1 mole on the bottom. After that, we need to change the grams into milligrams, and we will have the grams on the bottom and the milligram on top so that we can cancel grams. So when we look at the solution, it looks like this. 1.8 times 10 to the 17 molecules of sucrose, that's the given amount, and that's in the numerator. So it's like having a line under and then a 1 in the denominator. Multiplied by 1 mole of sucrose over the Avogadro number of molecules, because we want to cancel the units of molecules of sucrose. Next, we want to cancel the units of moles of sucrose. And so the molar mass will have to have the 1 mole on the bottom, so we can cancel units of moles, and then the grams on top. 342.34 grams of sucrose. And finally, we need to convert that to milligrams. So we will have the conversion between milligrams and grams such that the milligrams are on top and the grams on the bottom. This way we can cancel grams. And we are left with just units of milligrams, which is what we want. In the calculator, you do 1.8 times 10 to the 17 multiplied by 342.34 divided by 6.02 to 10 to the 23rd, and divided again because I didn't put parentheses, so I divide again by 0.001, and the calculator answer is 0.102326, etc. So that's the calculator answer here in milligrams of sucrose. And we have 2 sig figs only in the given amount, 1.8. 3 sig figs in the Avogadro number, 5 sig figs in the molar mass. So we can keep only 2 sig figs. The rest of what we have there are exact numbers, right? The definition of milligram is an exact number. So we need 2 sig figs. So we keep we keep the 1, and then the 0. What comes after the 0 is the 2, so we keep the 0, a 0. And that would be the final answer here in milligrams of sucrose, 0.10 milligrams of sucrose. So it's a small mass, but we can see that we had much less than a mole here when we started with the number of molecules. 10 to the 17 is, 10 to the 6 times less than the Avogadro number. So that's this much less than a mole. And so in a mole, we would have 350, about 350 grams of sucrose. So 10 to the 6 times less than that. That would mean, hold on. Yes, so 10 to the 6 times less, dividing the molar mass by 10 to the 6 would be 350 micrograms of sucrose. And because it's, about 2, 10 to the 17 compared to 6, 10 to the 23. So we have a third of 300, which is 100 micrograms, and 100 micrograms are 0.100 milligrams. So the answer makes sense. Sorry if you didn't follow, but I checked that the answer makes sense. And you should too, in your own way.